Since amines are bases and nucleophiles, amines can undergo reactions we've seen before. So amines can undergo substitution and elimination reactions, addition reactions, and oxidation reduction reactions. So stop the video and review the reactions on this slide. Let's apply your knowledge of organic chemistry reactions to predict the product of each reaction. So stop the video and draw the structure of each product. Note that MEI is methyl iodide. So the first reaction is a substitution reaction. The second reaction is also a substitution reaction, but it's a nucleophilic acyl substitution reaction, in which an acid reacts with an amine to form an amide. Two possible products form in this reaction. Let's do another practice problem. So stop the video and predict the product of each step in this reaction. The first step is a substitution reaction. Cyanide is a nucleophile, and it reacts with the alpha carbon. The Br leaves as leaving group and forms a nitrile. In the second step, the nitrile undergoes hydrolysis in a nucleophilic acyl substitution reaction to form an acid. Note that the nitrile carbon is an electrophile like the carbonyl carbon. In the third step, the acid reacts with ammonia with an acid catalyst to form an amide in a nucleophilic acyl substitution reaction. So remember, look at those structural features to help you predict the product of a reaction and use those curved arrows to show how bonds break and form. In an earlier video, we looked at electrophilic aromatic substitution reactions. For example, benzene undergoes nitration to form nitrobenzene. However, we did not look at how benzene can form a very common compound such as a phenol. One way to convert benzene to phenol is to go through an aryl diazonium ion. So note that nitrobenzene is reduced to aniline, and then aniline reacts with NaNa2 and HCl to form the aryl diazonium ion. So stop the video and determine whether this reaction is an oxidation reaction or a reduction reaction. So this reaction is an oxidation reaction. Note that NaNO2 is an oxidizing agent, and note that we see the loss of H going from aniline to the aryl diazonium ion. Once the aryl diazonium ion forms, it can react with water to form phenol. Another important reaction is the formation of an azo dye. So stop the video, draw a resin structure of the aryl diazonium ion, and show how it reacts with this compound in an electrophilic aromatic substitution reaction to form the azo dye. So here's the resin structure, and then the nucleophilic pi bond in the aromatic compound can react at the electrophilic nitrogen. So let's practice our organic chemistry skills. Stop the video, draw the structure of the product of each reaction. So in the first step, benzene undergoes nitration. In the second step, iron is a reducing agent, so the nitro group is reduced to an amine group. In this third step, NaNa2 is an oxidizing agent, so that's going to form the aryl diazonium ion. And in the last step, the aryl diazonium ion reacts with copper cyanide to form benzonitrile. Synthesis is a good way to review all the reactions that we've covered, so stop the video and propose an efficient synthesis. So let's look at those structural features and function groups to tell us how to figure out which reactions to use. So note that benzene has those nucleophilic pi bonds, but it undergoes electrophilic aromatic substitution. Note that the target compound also has the benzene ring, and it also has the amide functional group. So working backwards, we can make an amide from an acid and an amine. We might be able to make this amine by doing a Friedel-Crafts alkylation reaction, but the alkyl halide we need to use may not be easy to find off the shelf. Since amines are made by substitution reaction, we could try this. And then benzyl bromide can be made this way. Remember that NBS is that specialized brominating agent which brominates the benzyl carbon. And finally, we can make toluene from benzene by Freelicraft's alkylation reaction. So we have a pretty efficient 4-step synthesis.